Welcome back. Sorry, there was some technical problem. I didn't know it was working before, but I hope we should be good now, hopefully. And then let's get to business. So let's start. We are going to be checking about guided projects, project 1 from DataQuest. And then if you are just joining the stream, happy to be here. Thank you for joining. And let's just get to business. So if you have been following DataQuest, fundamental like the Python fundamental, and then the last mission there is just to solve this guided project. And today I want to show you how to go about it step by step. So let's go. I have started. I have started. I have started the streaming. So yeah, let's get to business. So the first thing you want to do is to go to your website and to go to the internet and just search for Anaconda, because we are going to need this tool to be able to use Jupyter Notebook. So I will just go and install Anaconda, yes. So we have this. Once you have that and you get it installed for both, maybe I should just take the other one. Yeah, this one is okay, the distribution. So you can install this Anaconda, and it has Python, it has so many kind of software you can actually use together with it. So you need this to write your code because it makes life really easy enough. So just install that. And there you go. So I will just close this. We don't really need it again, but then I'll quickly share this with everybody again so that we can all see. So quickly go here, Telegram, and just, so yeah. So here we are. So after you have installed your Anaconda, just like me, you can just type Anaconda from your computer. I'm on Mac computer, so it might be a little bit different on Windows. Doesn't matter. Just open it. Now it's opening up, I guess. Yes, it is there. I think I had one already. So you can easily launch Jupyter Notebook. This is what we wanted. You can also install this with pip and stuff like that, but I think this is the easiest way. Once you have it, you launch it. But I'm not going to be using this method. I'll be using a different approach. So I will just quit this one. What I would rather be using is starting it from the terminal. And then this is quite easy to go about. Just open a new terminal. I will come here. So the next logical thing you want to do is to just go to where you have your folder. For example, I've called it guided project. Just drag it and drop it there, enter. Then just type from your terminal Jupyter-notebook. There you have it. So it is going to open a new tab in Chrome or whatever you are using. And after that, you are going to start working. So I've closed this one, so we don't need this one again. We don't also need this one again. This is what we need. Good. So now that we are here already, I will show you something. I have all my data. So I have all my data, not this one. I have all my data in this same folder, because as you see later, when we have to read this information, it will be very good that we have it in the same folder. So the next thing you have to do is just to say new folder or something, new file, Python 3, and you can change the name or anything, like guided project as you like, guided project solution. So I'll be doing some copying and pasting from my own solution because I already have it. So I wouldn't want to be like spending a lot of time typing out some basic stuff. So quickly I would open also the one I've done before just to reference. So I'll go like this one, and then I think you have this one there and this one. So this one, good, there we go. So open this one again also in a new terminal. You go there, and of course the same command, Jupyter Notebook. I prefer to use this because I think it's kind of faster for me and easier to follow. So that's why I prefer to use this. So I will just start this again, just for some references for myself. And then there we go. So today, this is the outline of what we are going to be going about. Of course, we'll be discussing about the project, what are we supposed to do, and how are we supposed to go about it. Then, of course, we'll also be trying to understand the data that we are going to be working with. What kind of data we have, what is the shape, what is the size, how does it look like, and of course, most importantly, we'll be doing some analysis. But of course, before we do some analysis, we have to do a number of data cleanup, where we can actually clean up our data of some information that we don't want. And of course, at the end of the day, we would of course want to come to a conclusion. So, but I'm afraid maybe we are not able to do everything today. I think it's supposed to be in 2 parts because the whole thing is quite a lot. So we'll kind of maybe do it in 2 parts. Let's see how much we can go today. So as I said, the first thing is that, okay, you're going to come up with, because if you look at the instruction from DataQuest, this is the instruction, guided project, and they said, okay, I had a title, write a short introduction where you explain in 1 or 2 paragraphs what are you supposed to do. Because this same code, we can actually write it in other VS Code and stuff like that. But the power of Jupyter Notebook is that it gives you an extra power so that you can even write Markdown. You can write some like normal description text of what you're doing. You can show some graph visualization. Then you can actually write the code itself in Python. So all these 3 possibilities are what we have in Jupyter Notebook, and this is where we're actually using it. So I think you can maybe I might do another like a video on how to use Jupyter Notebook, but we are not going to be covering Jupyter Notebook in detail today. So let's just get to the business. So the first thing is like we should find some good title for our project, just to make it more descriptive enough. So I came up with something, I called it like a profitable iOS and Google Play app data to understand the most profitable app profile for company XYZ. So the main aim of all this analysis, because there must be some aim, there must be some goal at the end of the day, and why you're analyzing the data is because you want to get a better insight, you want to get a better understanding of what the data looks like, of what the shape and the size of this data, and how you're going to work with it. So we are like considering ourselves like this small app development company, and we don't want to sell apps, but of course we want to develop Google and then iOS apps, Android app and iOS apps, but we want them to be free, and not just only free, we want it to be in English, and of course also so that we can make money from an in-app advertisement. So it is for us to understand that, okay, in Google Play now, in iOS now, like what are the most popular free English apps? So all these criteria are free, English, and not just that they are popular, that people download them, but also people use them on like maybe 2 times in a week, 3 times in a week. There's also an engagement. So that is the main goal of this project. And we can actually put everything together in words, just like what I've put here. You can of course come up with your own like description, but it's just good to understand all this together. So I will just of course do some copying and pasting, which I don't know, yeah, we can do it, or I just use this one. So just to save time, I think maybe there is no need to do any copy. I might refer to that later if I need to show something really different. But at least let's just go like this. So as I said, the aim of the project is to understand free English apps where people use and mostly like engage in, so that we can know what our developers should also build some sort of free app. And by then, if people download more of our apps, we can probably sell some ads inside this app, as long as people use it, or when they click it, or when they just like see it. I mean, maybe number of impression or number of click. It depends. We're not going to be doing digital digital advertisement number of clicks here today. But yeah, it depends. This is just the aim of our project, as we can see. Then of course, it's very important to give some background information about the kind of data we have, so that at least our the people that are actually using this, that are actually reading this analysis that we are doing, they can have some background information. They can know the nature of our data. They can know the shape. They can know the size. They can know what the column head looks like. So this is what this section is all about. We are going to describe the data, and then as you can see, there are over 2 million iOS and of course over 2.1 million Android apps also. So there is like a lot of apps here and there, but then like sometimes you don't need to like take the entire population. It's like you want to analyze a human being. I mean, you want to understand human nature, you want to understand the system. You don't have to like take all the 7 billion people in this world and cut them inside, check their earth. Everybody is quite similar, so you can just take a sample. This is what we call sampling. So we got a minified version of this app, and then of this data. For example, we got only 700,000 for only 7,000 for iOS and only 10,000 for Android. So we can just visit the data just for us to familiarize ourselves with this information, and then here we go. So for example, the Google Play have this kind of information. Most importantly, we are interested in the head. I mean, the column head, how does it look like? Because as a result, we can kind of understand what this information kind of look like. So for example, we have our app names, of course. We have the category. Is it belonging into family? Is it belonging into like, does it belong to education, entertainment and stuff like that? Then of course the overall rating it has, and then most importantly the number of reviews, the size in megabytes, the number of install. There's a number of parameter. There's a number of information. For example, we have so there's a number of information that we can actually get to see in this kind of data, so that we can kind of like understand the kind of data we have. Yeah, I just see somebody is asking how to download the data. I think you can just go here, and then let me see. If you are using DataQuest, of course, you can. I think you can download from here, if I remember correctly. No, I think it's not from here, but maybe I can put the data up in my as an attachment later. Yeah, I think file download as, yeah, I cannot really remember how to download the data now, but I can put it up in the group or something later. So let's just continue. So that is for the Android. Now let's also quickly check for the iOS as well. Yeah, I put it also. I think maybe I should just share. Okay, I cannot share this. I can put it later. Let me see. I think you can. Yes, good. So I'll put this quickly. So this is the way you can copy link address. So I think that is for the Android, and this is for the iOS. Copy link address. IOS data. Yes, so there you have the two. Good. So you have the data now. I think you can later work with it, but let's just follow the discussion now. So for the iOS as well, it's pretty much similar. So I think I will just quickly show you the data, how it also looks like. So as you can see, just like of course the number 1 2 3 4, we don't know how long it is. We are going to check it with some code later. And of course some ID, some track name, the size in bytes, not megabyte now. Now this is very important, because if you think this is a megabyte, then you are working your code and it's going to give you some problem. So try to also understand the unit very well. This is in byte, while the other one is a megabyte. And of course, let's assume that we want to analyze like which kind of like category of app like the largest size, for example. So it's very good to pay attention to these units. And of course, the price, is it free, and the rating, and there's a number of like column that we'll be checking each one of them as long as we need them. And this is just some representation, some graphs and stuff, so you don't need to worry about this. So I think I will still leave them open for now. And as we see from our outline, now we understand the data, we know what we're supposed to do. The next logical step is now to start interacting with this data, because it is very important to interact with this data, see it, print it out, see how it looks like, number of columns, number of rows, what is the header like, and everything like this. So as a result, it's quite easy. So I think we can just quickly go back to the new template that we had, which was this one. So if you want to read the data, of course, a CSV data. There are different type of data format you can have. In this case, we are having it in CSV. As you can see, it's pretty much easier for you to just like do some magic with Python. So, for example, the first thing is for you to just import reader from CSV. So from CSV is a module, import reader. So now that you import reader, the next logical step is just for you to open the file. So open file. So I will just say open file or something. It's okay, you can call it anything you want. So open. So now in this case, we want to open, let's say, the apples. So it's already there because it's in the same file, in the same folder. That's what I was explaining. Make sure that, as you can see, if you go back here, in the same folder, in the parent folder, everything is in the same folder. Now these are the two datas. So, and this is the notebook, Jupyter notebook. That is why I can easily read it like this. And after you've already like opened the file, the next thing is like, yeah, it's there. And if you type, for example, you print it, it's not kind of readable now. Just to see, you can just open it and see. And let's just see. You see, sorry, okay, I have some typo syntax error, sorry. So yes, it's telling you some area text wrapper, whatever. Yeah, this is like some kind of object like data that you cannot really read. It has some IO wrapper, but that is not what we need. So we're supposed to make sure that this is in a format that we can actually understand and which is easier to work with, especially in Python. And that's why we import the reader. So the next thing we have to do is just to say like read file. So I will say read file. So then I'm going to use my reader now because it's just a function and it takes a parameter, and which is the open file. So if you want, you can still see it, and it's not going to be what you are really expecting, but just to let you see. You see, it's just also another like object also says we read the object. So these are kind of difficult to work with for our analysis, because what we want to do is at the end of the day we want to convert all these rows and all these columns, we want to convert it into big array. That means an array of arrays where each array inside the big array is a row. So this is one row, another row. So the entire data will be a big array. Oh, sorry, I keep saying array because I write more in JavaScript. Well, list, a big list in Python, as we say it in Python. So you have like this big list, and each row is like an element. It's just like one element. So it's like array of, it's like a list of lists. So this is what we want to achieve at the end of the day. So as a result, we will convert. And how do you convert? It's very easy. You just say like, so I can just say like, for example, this is App Store data. I'll say app. iOS, I'll just say iOS all or something. So I will just say list. Then just put the red file. Now, if you should print the same thing now, iOS all, is quite big, so it's like a lot, like, of course, you see. So this is a very good step. That means that we've been able to read, and if you can see, I will show you, we have this big, and if you go to the end somewhere, which I don't know how to get there, which is like, because it's very, very long, but just let's quickly scroll down, should also have the same thing. Good. This is like that big array I was telling you. Then of course at the beginning they have, this is one array, and that simply start from here. So now you see that this is like the last row. Why? This is the first row. So this is just the first row is starting from here. The first row is starting from here. And the ID, and it just ends somewhere here. Yes, somewhere here. So which means that those are the headers. The colon headers, so you can see in our, yeah, something like this, all this title, whatever, and all those stuff. So currency, so you can see ID track name. If I go back now, you should of course see the same thing, ID track name size. Voila, now we have read our data. So we will just do exactly the same thing also for our Android data, and that is it. But then, to just make life pretty much easier, this is like a lot of data. It's going to use a lot of resources, because like 7,000 rows. So sometimes you don't necessarily need all of this now. So why do you have to print everything? So I would rather just comment this. And since, you know, for example, these are string data, and these are like some data, like, yes, it helps us to understand the nature of our data, and the shape, the title, the column head, and all this kind of information. But when we start doing our analysis, our cleaning, we don't necessarily need this header side included. So we'll just say iOS header, just to like separate it. We'll just say iOS all, and just because, of course, as you can see, this is the first row. It starts here and it actually ends here. So this is the first row. You can easily take it as the first. So if I print it out and you see it, what does it look like? Just say header, and I run it again, and that's it. So that is your header, and so easy like that. So this is what we call array slicing, which if you don't get it right now, maybe I can probably later do something about array manipulation, about list manipulation in Python. And the next logical thing you want to do now, of course, you already have the header separated. You can of course also put the remaining row, which means all these remaining row without the heading till the end. So how do we do that? That is pretty much easy. You just go straight away and say iOS, let's say data or something now, the raw data. So that will just be iOS all, and one to the end. So you don't need to put the end, because we don't even know the end here. So the slicing is so easy that just leave it, start from 0, and the 1, which is the first, is going to be the first item here. So there you have it. So if we print it, because I wouldn't want to print the whole of this, of course I can just maybe put some space in between and just put some new line there just to create some space. Then I just go and I say iOS Oh yes, data. Yes, of course. I can put, let's say, just few rows or something. I don't know. So of course, remember this is excluding the header. Yeah, it starts with 0, but this is like the beginning of the beginning without the header. So let's just run this and see what we have. Yes, it doesn't come with the ID or whatever. This is just like the first 5 rows, because of course it excluded this. So that would be 0, 1, 2, 3, 4, and there we have it. So this is the first step we are actually doing here. So we read app data, app store data, and convert it into list of lists. And that is the code I just wrote there. Don't mind the naming here. You can name it anything you want. I just like to make my naming as explicit as possible, so that in case I come back, I can still remember what is doing what by just looking at a line. Of course, we also did the same thing for the. We also did the same thing also as well for the Google data, the Android data. It's just pretty much the same. If you like, you can just create one function and just put all these two data. But I think this is just, at least for clarity, this is okay. It's just exactly the same steps that we have taken. So after we have read in this data, we have converted it into a list of lists. Then the next thing we're supposed to do is just now let's start seeing how this data look like. What is the number of rows? What is the number of column? And all this kind of information that we would at least want to know about our data typically. Because understanding this as a data scientist, understanding this is very, very important, because if you know the shape and if you know the size of your data, it goes a long way for you to know how to work with it. Whereas if you don't really know how your data looks like, then it's like one is just walking blindfolded in a forest, in a dark forest. So it's good to print and print and print and print, especially. Use a lot of print as much as possible as you like, just for you to understand your data. So we are going to create this function, and this function, what does it do? Is okay. I will just quickly yeah. So basically, we want to create some sort of data to explore. For example, def explore data. So we're going to have the data itself, the data set itself, and we want to put some start and end. Then we want to check if we have row and column information. If we want to know this information, so of course sometimes we might want to know it. So the next logical steps here is that now, for example, if let's assume I just want to see what I did here, the first 10 rows, the first 20 rows. I don't need to keep logging all these data, the entire data every time. I can just do something called data slice, because it's just a slice of the data, and I can just say a data, then start, comma end. And remember, in most cases, whenever you said something slicing, the starting and the ending usually is not included. So if you want, let's say the first 10 rows, if you start, let's say, starting from 1, and you want the first 10, that means the ending should be 11. So, but if you start from 0, which is of course arrays are 0 based, that would be 0 to 10. So that is okay. So that is if you want to slice and see some. You can, that means this makes it so flexible that you can go, let's say, from row 20 to 40, row 100 to row 101. It just makes our life easier. But then I forgot to put something here, that this has to be false by default. Of course, we are just the one, we can create it to be anything as we want. But the point is that if, for example, if you want to see the information of this kind of the row and the column, let's say the number of rows we have and the number of columns we have in this kind of any data that we pass to this explore data function, we can then check, for example, if row and column is true. So if it is false, then we want to run something. So we just want to say so if row and column is true, for example, what do we want to do? Basically, we want to get a value for the row and the row length, for example, row length. So how do we get the row length? That is just quite easy. We just say length of the data. So by the time we say length of the data, and mind you, which kind of data? Is data that has the header or the data without the header? That also has to be taken account. Then how do we get the colon length? Colon length. So that would be length. So for example, data. So if you say data and you just say like, let's say the first one, for example, we just take any of the data, because remember, if you take 0 like this, that means the row. So if I want to know the number of columns, I can just go to this second row and say, okay, in this second row, how many columns are there? 1, 2, 3, and stuff like that. So yeah, that is that about that. Then of course, as a function, we should at least return something, right? So we can say return a row length, comma, or colon length. So I can just put something here if I want to put something here, comma, colon length. Then of course, for this one also we can just return. So if we don't have this condition, so we can just return the data slice or thereabout. So I think this should work. We can actually test it by calling the function now. So let's assume we want to play with the app store data that we have. We want to see it, how does it look normally. So we can just say explore data, and we just say, now what data are we going to use? Is it the one that has everything including the header, or the one that has only, without the header? So which means the second one, the IS data. So I think we should use the IS data, because then that we have removed the heading, so it makes our life pretty much easy. Then of course we want to put, let's say we want to start from, as I said, let's say 0 to 10, 0, 10. Then the point is that, do we want the row and the column, do we want it true or false? For example, let's say we want it false. So which means we don't even have to put this, because it's like a default argument already. So we don't really have to put, like, because it's the same thing that was there. So but if you want, you can still put it. So because of course we can just set this to like let's say results or something, so that we can print the result out at the end of the day. Then we can just say print results. So let's log it and see how it looks like. So as you can see now, we have the first 10 at least. We can say length just to see the length. Sorry, please let me know if I'm going too fast. I hope it's not too fast. So but anyway, so we can just go, as you can see, we have exactly 10 like rows, for example. So the flexibility of this function is that I can come and say, okay, I want from 101, I want to, like, let's say 1, or even say like 1, like 2000, for example, 2001 to 2005. So it's going to give me the information about this. Of course, this should be like 4, because it's 2001, 2002, 2003, 2004, excluding 2005 because it's the ending. When we slice, we don't include the ending. So as a result, we have that information. So I can of course remove the length and see the actual data itself, which is supposed to go like this now, which means that we have on this 2001, we have splash cars and stuff like that. So this is what we have, and of course followed by pattern something or whatever. So these are the information in these rows. So now we are like getting more flexible, unlike here where we just put like only, let's say, 0 to 5 and whatever. We've created a function that make us to like any, like just any row, and just any row range, we can actually get the information there. Now that is one thing, and that is okay. So let's assume now we want to know the row, and then the colon, how many rows is there and how many colon. You can just say row colon, for example, row colon. So we can just call the explore data again, and then iris data, for example, and then we want to say I don't know, like, yeah, I don't know if we have to pass anything here. I think maybe I have to cross check the function again. And then in this case, and I now said this to be true, right? So let's see what this one gives us. So row colon. So yeah, so this is quite interesting. And then I got a question from the live chart that why do we assign the row and the column false? Yeah, it's a very good question, because the default action we want is like we want to get a slice. Let's say from row 1 to row 20. But then if we want to do additional feature, we want to get additional information about our data, of course, we can, when we call this function, we can either choose to set it to be true or to be false. So as a result, we have the flexibility of doing some action on that condition. For example, if row and colon, we know originally if we pass it to be false, that means the whole of this block will not run ordinarily. Nothing will run here, right? So as a result, we are capable of like having this kind of toggle switch of which part of the code we want to run, which means that we don't necessarily want this part of the code to run. That's why we set it to false at the beginning. But as we want it to run normally, of course, we will make it to be true. So depending on the condition, on like what we wanted in our code, but in this case, we don't want this part of the code to run, at least at the beginning. And then we just want to get the data slice originally in this code. I mean, in this function. So that is why we set it to be false. As we can see here, we can see like we have 16 number of rows, because yeah, I will quickly do something just to make it clearer. I will make it like this. Okay, we have this. I will say row equals to 0, colon. So equals to row colon. So then I can print, I will just say row to be equals to, sorry, row to be equals to row, and I can print colon to be equals to colon. I think I have some syntax error there. Yes, so something like this. There's some syntax error. So if you go like this, can you see now? This is quite interesting. This is even better to see, because of course, if you just return this will return a tuple. That's why you see it like this. But even this second one even make it like easier, more like better to see. So we just destructure, like we just like what did they call it in Python? I forgot. We call it destructuring in JavaScript, but I think in Python they call it like I totally forgot now. But the bundling or unbundling or something. So, but anyway, we took out all these variables, all this data from row colon. We say, okay, row is this, colon is this. So, and according to the data we have like 16. If I go back again to we have like 16. This is 1, 2, 1, 2. Maybe does it start from the ID? 1, 2, 3. Anyway, we have like 16 minus the first one, because we are not considering this ID or something. This is just for the numbering. I think it's not part of the data. So I can log it again. ID track name. As you can see, it only starts from here. Though they wrote 17 column here because they also consider this numbering stuff. So that means we are correct. So we have, of course, like 16 columns, and we have like how many rows? Let's see it again. I cannot really remember how many rows we printed out. So we have 7,197 rows. Now, mind you, this is because we have removed the header. As you can see here, the header, because we use iOS data, we minus the header. So that is excluding the header. If you put the header, then of course this will be like +1. That will be 7198. So that is that about that. So we can quickly cross check because I'm not sure if I remember everything. Yeah, so yeah, exactly. That is what we did. Also, like it's just the same thing. So they just like we just have like from DataQuest, I think we have additional thing to just print the rows and everything. So you loop through the dataset slice and you just print each row, which it's okay. We can do it in different ways, but this is just the logic. As you can see, 7197, 7197. So it's the same thing that we have done, and it has actually make our life easier. So I don't want to repeat again for Android. It's just exactly the same. The only difference is just that we'll pass, instead of passing iOS data here, we will just pass Android data. So just to like make sure that at least I will just come here and say row colon, I will just say iOS, just to make it like just to make it iOS. Yeah, row colon iOS. Yeah, good. So just to make it like easy to also see at least something from Android. So we'll just say print, and we'll say I will just copy exactly the same thing. I will just print it out straight away without assigning to any variables. So I think I'll call it false at the beginning, which you don't even need this at all now because it's actually false by default. So for example, I will just say here, now I need to quickly create this data for Android, which I will quickly go now. Yes, I will just copy exactly the same thing and just change this information to Android or something. So Android, and then I would rather call this Android data also. Yeah, iOS data, I'll call it Android. Please let me know if I'm too fast, and I hope you are still getting everything I'm saying so far. So I'll also call it Android. Yes, so we'll just change this to Android, or they call it Google something. I cannot remember what they call it. Oh no, I think it's not this one. I think it's Google Play or something. Yeah, Google Play Store. So there we have it. So we also have something. Yeah, we also have something for the Android. Or is it still referring? Let me see. Is it still referring the same thing? Track name, size by. Okay. I think there's something still wrong there. Open reader red file. Okay, good. I should call it Android all here. Okay, good. Android all. Okay, there we have it. Now we have the correct data from the Android also. I just want us to at least also explore the data and see a little bit. We don't have to do this, but of course, it's okay if you have some little bit time. And I think time has really gone so much. So I don't know how much you can still do today. But yeah, we would see. I don't just want the session to be too long. And sorry for some sort of like problem with the technical issues. So yeah, let's go and just continue. So we'll just do exactly the same thing here as I call it Android data. So I think I'll quickly print a new line here just to make some gap. So I'll just call it new line. Good. So now let's print it. Good. As you can see now, we have a different data entirely from the Android data. And of course, you can also just try to see the information about the rows and the column. So I will say rows and column, and I will just say true. So let's see what this one also gives us. Yes, and that gives us 13 and 10841 exactly. So that is the number of rows and column that we have also. I think I would print it also better like I printed for this. Okay, so I will just call this row colon iOS. row colon, I will call it iOS also, yeah, row colon iOS, good. So I'll just call this row colon Android, good. So yep, I think is not defined. Row colon Android is not defined. Yeah, because of course we did not have something like this there. So I will just quickly put this here. So colon Android. So I'll change this to Android data. Yep, there we have it. So maybe I will just comment this one now. We don't really need it again. So good. So we have 13 columns and we have 10841, and I think it's also the same here. So you can see 13 columns, and of course the number of rows is 10841. So that is what we have so far, but I will just quickly rush through a little bit part of. We are going to the third part now, which is a little bit difficult for some people so far, as they have showed in the group, but I will discuss what we are supposed to do. I will discuss what we are supposed to do in this part. So just to get you back, we have covered from part 1 and this, we have covered this. We have covered this reading and exploring data. Now we're supposed to go to data cleaning step. Mind you, data cleaning is like, I think I read it somewhere like, it's like for data scientists, it's like 80% of the job, because you have to clean your data. You will not always get the clean data. And even though if you get the clean data, it might not be in the shape, in the size that you want. You might want to change something just to make your analysis better and faster and easier. So data cleaning is like the most important thing that you have to do. So once you clean your data according to your own criteria, according to the project criteria, according to your client criteria, it makes your life really, really, really easy. So, yep. So normally when we write code, when we generate data, when we fill forms, sometimes some people, like maybe there's some places there's some wrong validation. I'm talking like a web developer now, like you forgot to validate something, and people, they did not put some information that they would have supposed to put, or even is even optional. And when we are like analyzing data, sometimes it gives us some sort of outliers, some sort of like wrong information that could affect our results. So that's what we call missing columns or missing data points. So this is very, very, very important, and it's like for a data scientist, you must take note of this. And then when you see a data, a lot of people that work with the same data, they might say, okay, column this is row this is having this problem, row that is having that problem. For example, as you can see from the discussion forum, some people said 10472 from the Google, but then from the Android app data is having problem. So we have to remove it somehow, because for example, it has a missing column. It has like, let's say, instead of 13 columns for the Android, it has like 10, it has like 11. So if you're not very careful, this will affect our results at the end of the day. Now it's only one, but let's assume it's 20, it's 50, it's 100. And then this will just cause us to make some wrong information about our data. So just to get familiar with this, of course, this is very easy to do. You just say delete the data and you put the index. But this is kind of nice to do and it's very easy. But I'll quickly discuss this other way that we find out also. Brainstorming and stuff like this. And we actually come up and we found out that there's even a better way to check and delete, because if we don't have this information initially, how do we even get it? So there is this nice function here which I will quickly just also work over there, and I think after that we are going to stop because the next one could take a little bit more time to explain. So there we go. So I'll quickly just open a new cell here, and I will explain each line one by one. Or maybe I will just delete everything and write it again. But anyway, now we want to remove a column with less, a row with less column or with some missing information. And the first logical step is that we have to loop through the data. For example, from here, for row in data, so it can be like the app data, the Android data, it can be the iOS data. Then I'm checking if the length of the row, this particular row, I will show you what I mean from here. I'm saying that go to each, because you remember this is a list of lists. So we have this big list, and from that big list, each row is like another list inside that big list. So I say, okay, for each row, that's why I said for row in data or in the list, if this particular row, when you check the length, if the length is less than the length of the header, because we are rest assured that our header length is okay, because you remember we have actually used it to check. I think at the beginning we have used it to check, where was it, somewhere here, yeah, column length. We use it to check here. Of course, this is, I think this is without the header, but anyway, it's the header. Usually if it is not a very, very bad data, the header should always, because that is the column. If there is an header, then that means there is a column. So we are quite confident that, of course, we should have an information for our header. So that is why we are running this code like this. Now, under this condition, if we have the length of that row, if it is less than the length of, for example, I'm supposed to write the data here, sorry about that, but you know what I mean. If it is less than the data, I will just say data. So I will just say data. Yes, data, the length of the data itself, which is the header. No, that was correct earlier. That was correct. So I can just to make the code like better to use, I might say the data, then, because we already have the header, I call it something different here. So I'll quickly correct that. For example, I call it here Android header. Yes. If it is less than the Android header, which in this case normally is the header of the Android data. So we want to, of course, print the row first. We want to see that row that has a problem. And of course, we also want to check the length of this row. Is it 10? Is it 11? Normally, we already know that this should have at least 13 columns, right? So if the colon in this particular row is less than the colon is in the header, they want to check it. Then at the end of the day, want to see what index it is. And this is how you get the index. You just take the data and you say index, of course, then the row. You just pass the data, then that's going to give you the index. And of course, after that, we want to delete it because it's not good information. We don't want it. So we want to go, because it's like a loop. Anyone that has this kind of problem, we just get deleted. So let's just run this code and see what happened. So we don't have this data, so I would just say Android data or something. I think I call it Android all here. Remove less, so Android data, sorry, not all. So Android data, yes. So good, perfect. So as you see now, we already realized that this is the problem. This is the one that has a problem. It is actually 12 column instead of 13, and this is the index. Then remember at the beginning we have this to be 10841. Now it has removed 1. Now it's 10840. Mind you, you don't have to run this 2 times. Yeah, okay, good. This is perfect. This still works. You still have the same length. So because of course there's no any other one that has the same problem. So I think this is more robust solution compared to this other solution where you just delete with just one, like this one, delete with the index, because you can see it's the same index number that we later got, 10472. So I think for now we are going to be stopping now. Thank you very much for joining, and then see you some other time. Thank you. Bye.